Hello everyone, in this video we're looking at how to integrate a range of hyperbolic functions. We'll cover integrating inverse hyperbolic functions using standard integrals, integrating sin of x squared using hyperbolic identities, and proving the integral of sec of x using substitution. Okay, so in example 1, we're going to integrate 3 over the square root of x squared plus 1, and we're given these standard integrals. So you can see this integral is similar to what we have here. We have the x squared term, the a squared is the constant, and this is 1. So because a squared is equal to 1, we know that a will equal 1. And this numerator of 3 we can bring out in front of our integral. So we'll have 3 times the integral of 1 over x squared plus 1. All square rooted and integrated with respect to x. So now this is exactly the same as what we have here. So the integral will be 3 times the r sin of x over a. So just x plus the constant term, okay? And for question B, we can bring this numerator of 4 out in front because it's a constant. So we have 4 times the integral of 1 over the square root of x squared minus 25 with respect to x. And now you can see we're looking at this integral where a squared is 25. And if a squared is 25, a will equal 5. So the integral will be 4 times the integral of this, which is given as r cos of x over a, and a is given as 5, and we'll add the constant of integration. Okay, so this is how you integrate with standard integrals. In question 2, we're going to use hyperbolic identities to integrate with sin of x squared. So in its current form, this is very difficult to integrate, but we can write it in a more convenient form using this identity here. And we'll begin by making the sin of x squared the subject of this identity. So sin squared x will equal cos 2x minus the cos squared of x. And now we need to write this cos squared of x in terms of sin squared of x, which we can do using this identity, where we'll make cos squared of x the subject. So I'll draw a little box around this in purple, and we'll say that cos squared of x is equal to 1 plus sin squared of x. And then we'll substitute all of this into here. So we get sin squared of x is equal to cos 2x minus 1 plus sin squared of x. We'll expand out these brackets. So we get minus 1 minus sin squared of x. And then we'll move this to the left hand side. So 2 sin squared of x is equal to cos 2x minus 1. And then we'll divide both sides by 2. So sin squared of x will equal cos 2x minus 1 all over 2. And it is this which we can integrate because this is exactly the same as the sin squared of x. And we can move this division of 2 out in front of our integral, again because it's a constant. So we'll have 1/2 times the integral of cos 2x minus 1 dx. And now we can use the reverse chain rule to integrate cos 2x, and this will give us 1/2 of sin 2x. When we integrate the negative 1, we get negative x, and then we'll plus a constant, we'll expand these brackets out again. So we get 1/4 of sine 2x minus 1/2 of x plus the constant. Okay? And in question 3, we're going to use the method of substitution, where we'll let u equal e to the x to show that the integral of sesh of x with respect to x is 2 r fan of ex plus constant. So the first thing we're going to do is we're going to write this as 1 over cosh of x. So what we're going to work out is the integral of 1 over cosh of x with respect to x. And we know that cosh of x is equal to e to the x plus e to the minus x over 2. And when we work out 1 divided by this, we have the integral of 2 over e to the x plus e to the minus x with respect to x. So the next thing is to move this constant of 2 out in front of our integral, and this will leave us 1 over e to the x plus e to the minus x with respect to x. Now if you look at our standard integral, we have an x term and a constant, and we can get each of these by multiplying both the numerator and denominator by e to the x. Because what will happen is, we'll have 1 times e to the x, so e to the x, over, we'll multiply this by itself, so we'll get e to the 2x, or e to the x squared. And when we multiply e to the negative x by x, we add these powers, we get e to the 0, which is 1. And then we'll write the dx. And in the question, we're told to use the substitution that u equals e to the x. So we'll write this in terms of u. We have 2 times the integral of u over u squared plus 1. And when we find du by dx, we get e to the x, which is also equal to u. So therefore, dx will be equal to du over u. So we'll write this in our integral, du over u. Now you can see that this u and this u will cancel. So we'll cross these out. And now what we need to find is 2 times the integral of 1 over u squared plus 1, integrated with respect to u. And using this standard integral, we know that a is equal to 1, x is equal to u, so we have 2 lots of r fan of u over 1, which is just u, plus the constant. And finally, we know u is e to the x, so we've got 2 r fan of e to the x plus the constant, which is exactly what we were trying to find. Okay? Well, I hope that's given you a clearer idea on how to integrate with hyperbolics. If you found this tutorial helpful, please hit that like button, share it with your friends, and don't forget to subscribe for more further maths and GCSE tutorials. Thanks again for watching. You can download the full lesson and worksheet from my website, mrmathematics.com.